Okay, this is question number 9. We need to have a circle, so let me draw the circle. Okay, alright. So we need the following points. So this is the center. So a diameter is drawn. This is AC, and we have a point there B, and B is connected to C, and we have a line passing from B to D, and D is connected to C. Okay, so this is the geometry, and we have this to be as 3p, this to be as 2p, this to be as q, and this to be as r. The question is as follows. The question wants us to state the reason why angle ABC is 90 degrees. Okay, this is a valid question. Now if you were to see ABC, we are actually talking about the angle here. Okay, this angle is 90 degree. The question is why. Now I'm going to give you the reason. We observe that AC is a side of triangle ABC, and AC is the diameter. Now, by geometry, angle created in the semicircle is always equal to 90 degree. Okay, so this means angle B is equal to 90 degrees. That's exactly what they want. Now this is one definition. I want to give you the second definition also. In triangle ABC, we observe that AC, being a side of triangle ABC, is also the diameter. So this is a very important theorem. By Thales theorem, the angle opposite to the diameter is always equal to 90 degrees. This implies angle B is equal to 90 degree. Okay, hence the required so you can use either this or this, right? But remember, once you have a diameter, the angle opposite to the diameter will always be equal to 90 degrees. So let's move on. Okay, this is the second question. We are expected to find angle BAC. So this angle is required. Now if you observe this diagram, BAC is a triangle, and one angle of the triangle is already found to be as 90 degrees. Okay, so we got 3p here on the other side and 2p on this side, and we know the sum of the angles in a triangle equals 180 degrees. So that's the concept I'm going to be using here. Okay, so we observe that BAC is a triangle with angle at B is equal to 90 degree. By triangle law, the sum of angles in a triangle equals 180 degree. This means angle at B plus angle at A plus angle at C is equal to 180 degrees. Angle at B is 90 degrees. Angle at A is 2p, angle at C is 3p. So 2p plus 3p is equal to 180. You add these two things, you get 5p. You push this to the other side, you get negative 90. So this is going to be 90. So 5p is equal to 90 divided by 5. You get p is equal to 5 divides 90 how many times? One time, and then you carry 4 to the other side, and it's going to be 18 degrees, right? But this is 2p. Since angle A is equal to 2 into p, which is nothing but 2 into 18, which is nothing but 36 degrees. This is the angle at A. Angle at C also we can calculate. Okay, so I'm writing it here. Also, angle at C is 3 into p, which is nothing but 3 times 18, which means I3s are 24 to 54 degrees. So this is the angle at C. Okay, we are asked to find the angle D now. Okay, or what is angle Q? Now just observe here, this chord BC subtends the angle at A. Now the same chord is responsible in subtending the angle at D. Now by angle chord theorem, if the chord is responsible in subtending multiple angles, then that chord which creates that angle will create angles which are one and the same. That is to state that if the chord BC is creating this angle, say 36 degrees, then if this chord BC creates multiple angles within the circle, then all of these angles created by this particular chord will be 36 degrees only. I'm going to use that same logic, and I'm going to state that the angle Q is also equal to the angle at A. So clearly we see that the angle at A is 36 degrees. So that would be the conclusion for Q. Okay, so I'm going to state here, by angle chord theorem, we know that the angle subtended by the same chord are always equal. Okay, since chord BC subtends angle A and angle D, angle A and angle D. This means angle A is equal to angle D. Since angle A is equal to 36 degrees, this means angle D is equal to 36 degrees, which also means Q is equal to 36 degrees. Okay, so that's the solution for this question. Okay, the next they are asking us to find the angle R. Now clearly you see this angle at C is 90 degree by the definition that I've just shown you at the start of this question. Angles created opposite to the diameter is always 90 degree. So we can utilize that concept and find out the value of R. Okay, I'm going to state here. Since angle C is the angle opposite the diameter, and we also know that the angle created in the semicircle is always equal to 90 degrees. This means angle C is equal to 90 degrees. Now since 3p plus r, angle C is equal to 3p plus r, and p is equal to 18 degrees, this means 3 times of 18 plus r is equal to 90 degrees, which means 54 plus r is equal to 90 degrees, which means r is equal to 90 minus 54, which means r is equal to 36 degrees. So that is the conclusion for this particular question. Okay, let's move on. Okay, so this is the next question. Let me write this down. From a harbor H, the bearing of two buoys S and Q are 185 degrees and 311 degrees respectively. Q is 5.4 km from H and S is 3.5 km from H. So we need the diagram. Let me draw the diagram. So foremost, when we are talking about bearings, we need the north. Okay, so this is the point of the harbor. Now this is Q and this is our S. This point is going to be our edge. So this distance is 5.4. This distance is 3.5. Now this is given. This entire degree is given as 185, and we have to find this. Now the position of S, I would say Q is given as 311 degrees. From 311 we take away 185, and that would give us 6, 2 and 126 degrees. So this is what is required, 126 degrees. Next they are asking us to find this distance QS. So we will use the cosine rule. We will use the cosine rule, which is QS squared is equal to HS squared plus HQ squared minus 2 times HS times HQ times cos of the angle between HS and HQ. That's going to be 126 degrees. So HS squared is 3.5 squared and HQ squared is 5.4 squared. 2 times 3.5 times 5.4 times cos of 126 degrees, that's a negative 0.588. So we will have to evaluate this. So 3.5 squared gives you 12.25 and 5.4 gives you squared gives you 29.16, followed by multiplying this entire string This is going to give you negative 22.218. Now if you add up and simplify, you get 63.63 approximately. This is QS squared. So we need QS. QS is going to be square root of 63.63, which is approximately equal to 7.98 km. This is my QS. Okay, next is they are asking us to calculate the bearing of S from Q. So for that we need this angle. Okay, so we will use sine rule. So I'm going to state it here. By sine rule, this side 3.5 divided by opposite angle, that's sine of Q, angle Q, is equal to this side. We have got this side as 7.98 over sine of 110 degrees. So I hope you're watching it, right? This is the equation setup. So therefore 3.5 multiplied with sine 126 degrees divided by 7.98 will be equal to the sine of the angle Q. Okay, so if we were to evaluate, we will get sine of angle Q to be equal to 0.355. So angle Q is sine inverse of 0.355. So if you were to calculate that, angle Q is 20.8 degrees. Now they want us to get the bearing. So bearing of S from Q, to get that, to 90 degree we add 20.8 and 41. So if you had to perform this addition, you will get 151.8 degrees. Okay, so that will be the solution for this question.